Okay, started. Maxwell's equations, electromagnetics 2. That's the first chapter of EM2, electromagnetics 2. And that's my name. You do not know me, Muhammad Al Salama. Please solve as many problems as you can. Please read this and implement it, not only read it. Because in any course, if you do not solve problems, you cannot solve problems at the exam. I hope that solving problems will not be the first. I mean that solution of problems will not be the first time you see in your exam. I hope that you try this before the exam. I hope that you do not try solving problems at the exam. You have to try that before the exam, not in the exam. So this is very important, okay? Very important. This note is very important. Okay. Okay, this is in the time domain. Now time domain. Okay, differential form of Maxwell's equations in the time domain. We have this equation is what? This is Gauss's law. Del dot D equal rho. D is the displacement vector, electric displacement vector, or electric flux density vector. D. The divergence of the flux gives you the source. The source is rho v. This should be rho v. Rho v, which is the volume charge density. Let me just correct it here. Rho v. Script. Rho v. This should be rho v, and del dot b equals 0. The divergence of the magnetic flux density is equal to 0. Why? What's the source of the magnetic flux density? The current, yes. And the current, when there is current, you will have always south and north poles. So the total pole count is 0 because north plus south is equal to 0. So there is no magnetic charge. That's why we have del dot B equals 0. So the electric charge rho v is the source of the electric field. Okay. But for the magnetic field, there is no magnetic charge. Okay. That's all. And sorry. Del cross E equal minus dB by dt. This is Faraday's law. The curl in the electric field, the rotation in the electric field, of course, for static fields, for EM1, del cross E equal to 0 always. Del cross E is equal to 0 because there is no time rate of change. There is no change with respect to time in the for the electric or magnetic fields. So here, del cross E equal minus dB by dt. The time changing magnetic field produces curl or rotation in the electric field, which produces voltage around the closed loop. Therefore, if you integrate the electric field around the closed loop for EM1, the result will be 0. For EM2, the result is not 0. It will equal the induced electric field or the induced voltage. So integrating the electric field around the closed loop for static fields produces 0 result. For dynamic fields or for time varying fields, the result is not 0. Okay. And we have shown many applications for Faraday's law in the previous semester for EM1. Okay, many applications, including, for example, the motor and the generator for electricity, which are very important. Almost you have motor in every equipment for airplanes, for cars, for the dynamo, for example, in the car is electric. Okay, del cross H is equal J plus dd by dt. A similar, so here the source of the curl of electric field is the time varying magnetic field. The source of the magnetic field is the electric current, and this is displacement current, which is just the derivative of the displacement electric vector. So the source of the curl of electric field is the time varying magnetic field, and the source. Yes, I have pen here. Why not? Okay. So the source for the curl of electric field or rotation is the time varying magnetic field, and the source for the rotation of magnetic field is, or the magnetic field itself is the electric current, this electric current, and this is electric displacement current. Okay. The source for the electric flux is the charge, electric charge. The magnetic charge is equal to 0. Now these equations, these are 3 equations here, yes? Because dx, dy, dz, 3 components. Okay, so we'll have 3 equations. And this here will have 3 equations, 6 equations, okay? And this here, 3 equations, and here 3 equations, 12 equations. And how many unknowns? Or it is here, okay, and rho v. So we need auxiliary relations to complete the information. Yeah, but rho v is cannot. So this should be one equation because rho v is scalar. Okay. Auxiliary relations to complete the information. Force law, we have also studied that in EM1. We have the total force is equal electric force, which is Q times E. Q is the electric charge, and E is the electric field. So the electric field exerts force on electric charge Q evaluated by Q times E. And the magnetic force is Q times V cross B. Q is the electric charge, as we said, and V, the velocity of the charge, and B, the magnetic flux density. The force is measured in newtons. Ohm's law for a conductor, J equals sigma E. J is the volume electric current density in ampere per meter squared, volume in ampere per meter squared, not ampere per meter cubed, per meter squared. And sigma is the electric conductivity, Siemens per meter. E is the electric field in volt per meter. The convection current for charge is J equal rho V. Here in insulator, there is no, here in conductor, okay? Here insulator, there is no conductor. Sigma equal to 0. So J equal rho V. Rho is the volume charge density and V velocity. I will also, this should be rho V. Okay. Equal rho V. Okay. Now the electric, those all are called auxiliary relations. auxiliary relations يعني إضافية أو مساعدة. هي علاقات مساعدة إضافية حتى تقدر تحل المسائل هنو، لأنه هون في عندك إذا بتحسبهم equations عاديات في عندك 4 equations. و how many unknowns? We have D, we have rho, we have B, we have E, we have H, and we have J. Okay, the unknowns are more than the equations, so we need more equations to, or extra equations to be able to solve these equations. The electric constant, you know that also, D equal epsilon E, epsilon electric permittivity in farad per meter, and epsilon R relative permittivity has no units. Epsilon naught is permittivity of free space, which is equal 8.854 10 to minus 12 farad per meter, or 10 to minus 9 over 36 pi farad per meter. Permeability, similarly, B equal mu H. B is magnetic permeability, and the mu R relative permeability has no units, of course, and the mu naught permeability of free space, which is 4 pi 10 to minus 7 Henry per meter. Okay. That's all. So we have the current, the force, and the dielectric constant and permeability. Epsilon r is also called dielectric constant. Has no names. You call it, you see, I will see if, oh, it's okay. So epsilon r has two names. One name is relative permittivity, and another name is dielectric constant. The same. Now, Maxwell equation in integral form. The previous form were differential form, in the form of differential equations. Now, integral equations. This is Gauss's law. We said del dot B equal rho V. Equal rho B. Okay. So if you integrate both sides, so integration of rho V dV here, rho V, integration over the volume, this is volume, and this is rho V. Integration of rho V dV over the, it will give you the total charge. Total charge is the integration of d dot ds, because d is coulomb per meter squared. If you integrate over the closed surface, you will obtain the total charge enclosed within the surface. So if you have this volume, okay, which has outer surface S, closed surface, of course. If you integrate d over the normal component, because S is the surface, which is the normal to the surface direction. So integration of the normal component of d to the surface is equal the total charge enclosed. So this is equal Q enclosed. Q enclosed. Okay, this is Gauss's law. And similarly, since the total magnetic charge is equal to 0, magnetic charge is 0. So if you integrate B over closed surface, you will obtain 0, because this is the charge enclosed. There is no magnetic charge. So it is 0. Also, if you integrate E dot dl, you will obtain the voltage. Integration of electric field over a closed path is equal the electric field, the potential difference, the voltage. If there is no time variation, this will be 0 in static fields. If there is time variation, the result is not 0. It is equal minus d by dt integration b dot ds. This is Faraday's law. We said that V induced, voltage induced, okay. So EM2 is similar to EM1, but with the extension to time varying magnetic fields. So if you are good in EM1, I assume that you will be good also in EM2. V induced is equal minus d by dt psi m, magnetic flux. V induced is equal integration A dot dl, and d by dt minus the, and flux is equal integration of B dot ds. So this is the Faraday's law of induction. And here similar to del cross E, del cross H equal the conduction current density J plus dD by dt, displacement current density. You just derive d with respect to time, you will obtain the displacement current density. Okay. If you integrate both sides, okay, integration del cross H dot d v ds عفوا ds, yes, yes. Using Stokes' theorem, this will be integration H dot dl. Okay. And here we have integration J dot ds, and here integration D dot ds, and we have d by dt. So just integration of this equation, or both sides of this equation. So the total current is the conduction current plus displacement current. That's so. Now, this equation, if you take dot product of both sides with the del operator, del dot, del cross h plus equal j plus dd by dt, this will be 0 because del dot del cross, this is normal and this is in the same direction. So it will be 0. Okay. The direction is normal to del here. Del cross h direction normal to del. If you dot product of a vector with another vector which is normal to it, the result is 0 because cosine 90 degrees is 0. So this is 0. Okay. Now del dot j here, and here we have d by dt del dot d. Okay. Now del dot d equal rho v from Gauss's law. So I have put here rho v. So del dot j plus d by dt of rho v equals 0. Del dot g, if you take it here, okay, you will have this here minus d rho by dt, rho v. So the decrease or the increase in the current, okay, for a certain volume means that if the current goes outside a volume, this means that the charge will decrease, minus sign. If the current flows inside a volume, the charge will increase. That's the law of conservation of charge. If the current here goes out of the surface or of the volume, the charge will decrease, and vice versa. Okay. Any questions up to now? No questions? No, any question? Everything is clear? Okay. Let me see this. Why is it like that? Okay, this needs. Just correct this. Okay, now okay. Okay. Here we have this circuit, electric circuit. We have source V naught cosine omega t, simple source, and we have the capacitor, and we have this the current in the capacitor. Okay, and this is the capacitor, parallel plate capacitor, area A here, and the distance between the plates is d, and the permittivity of the medium inside is epsilon. So we want to show that the conduction here there is conduction current, I conduction, yes. And inside here there's insulator, so it's not conduction. So it is I displacement, okay? I displacement current. Here there is no conduction current inside. So we want to show that the conduction current outside the capacitor is equal displacement current inside the capacitor. Displacement current in insulators, okay, where there is no charge. There is no free charge to move. We want to show this. Conduction current is equal, you know that from electric circuit, C dV by dt. This is voltage. Derive this with respect to time. You have V naught omega sine omega t with minus sign. Okay. Omega, sorry, dV by dt. Here, I think IC equals C dV by dt. I think there is something not right here. Something not okay here. E equal, sorry. C dV by dt. I think this is not okay here. It's not like this. This should be sine, because unless this was sine, for example, maybe this was sine and this cosine. There is some, I will see the original file. I have original file here. I will see this is Maxwell's equations. Wait a minute. Maxwell here. Okay, just let me see this. we have another file. Just to see what's here. Okay. Oh, it's sine. Yes, that's right. This is should be V naught sine omega t. So here is the mistake. I will correct this and I will upload it again to the sine. So this is sine, not cosine. Sine, okay. So this is V naught sine omega t, not cosine. So this is wrong. This should be, this is not okay. Okay, this is wrong. This should be sine, not cosine. This is sine. Sine omega t. So C dV by dt, C, this is C, and dV by dt is omega V naught cosine omega t. Omega V naught cosine omega t. So that's okay. Now E equal V over D. So this should be also sine. It's not okay. Be sine. So V naught sine omega t over D, because V over D, this is V. Sine omega t. Let me just make sure. Yes, sine omega t over D. Okay, I will correct this also here. Also, this should be sine. This is the first time I am using these typed notes. Previously, I was using handwritten notes, so the timing maybe have some typo mistakes. Okay, let's continue. So we have this is sine. Displacement current is equal epsilon dE by dt. This is E. Epsilon is as it is, and V naught over D, here V naught over D, okay. Derivative of sine is omega times cosine. Omega times cosine, okay. Total displacement current is you multiply by the area because it is uniform here. The area is A, so multiply this omega, here omega, epsilon, V naught over D, you multiply only by A, and cosine is here cosine. Okay. We know from circuit that epsilon O over D is equal to C. Yes, this is the capacitance. This is the capacitance. Omega is as it is, and V naught as it is, and cosine is as it is. So this is total displacement current. Now we want to find the total conduction current. Total conduction current is here. It is given here. So if you compare, I will reduce the size to compare. If you compare this conduction current with the displacement current, this, it is exactly the same. Omega C V naught cosine omega t. So displacement current is equal to conduction current, as it should be. Simple. Now, if you want the time harmonic, a time harmonic case, okay. Time harmonic case means that you have single frequency, sinusoidal frequency. So d by dt will be replaced by j omega because we assume that it is exponential. You know, cosine and sine is the, real part and imaginary part of exponential j omega t. J omega t. I think they call this formula Euler formula. EULER, Euler formula. So this is cosine omega t. Okay. Cosine omega t plus j sine omega t. So if you take the real part, it will be cosine omega t. So we replace cosine omega t by exponential j omega t. So if you derive exponential j omega t, what's the derivative of exponential j omega t? It is the same multiplied by j omega. Okay. It will go to j omega times exponential j omega t. here d by dt exponential j omega t. So derivative of the equation will be replaced by j omega because exponential j omega t is the same as the original one. So you replace every derivative by j omega. We have del dot d equal rho v. Here we do not have d by dt, so it will be the same, but this will be frequency domain, not time domain. I would correct here also. Update this here. Okay. Okay. Okay, here. So it is del dot d equal rho v. Del dot b equals 0. There is no time domain here. There is no time derivative, I mean. And del cross E equal minus dB by dt. We replace d by dt by minus j omega, by j omega. This was equal del cross E equal minus dB by dt. d by dt is j omega. And del cross h equal j plus dd by dt. d by dt is replaced by j omega. Also, auxiliary relations, J equals sigma E. There is no d by dt. It will be, the form will be the same, but this, the first one was in time domain, now in a frequency domain. D equal epsilon E, also there is no time derivative. B equal mu h, there is no time derivative. Note that the symbols in these equations represent the complex multipliers of exponential j omega t. The complex scalar quantities are called phasors. Okay. نسميها phasor. تعرفوا هذا from circuits. I think I will stop here. It's enough. And we will continue because we have a new topic now. Continue later on.